All right, so this is the key to quiz number 3. And in number 1, you want to write this equation of a circle that's in general form, and you want to write it in standard form. So you write it in this form: x minus h squared plus y minus k squared equals r squared. Now remember, the first thing you have to do is you've got to bring all the constants to the other side. So we need to subtract 4 from both sides. So let's go and do that now. So then also we have to group the x terms together, and we need to group the y terms together. And so when I'm going to rewrite this, I'm going to write it as x squared minus 10x. And then remember, when completing the square, we're going to add some number, some constant to these two terms right here. And then the same thing over here. When we group this, we're going to get y squared plus 8y. And then when I complete the square on the y's, we're going to be adding a term to these two as well. And then that's going to equal, and then 8 minus 4 is 4. All right, so let's go ahead and figure out what this right here must be. Now remember, the point, whatever you add here, whatever this is, you've got to make this a perfect square trinomial, so that way it looks like a binomial squared. So a perfect square trinomial is a trinomial that can be written as a binomial squared. So we got to figure out what number needs to go here to get this to look like a binomial squared, and the same thing for this, to get that to look like a binomial squared. All right, so remember what we did. So to do that, you're going to take the coefficient of x, which is negative 10, and you can divide it by 2. It's always divided by 2. Whatever that quotient is here, you're going to square that. So this becomes a negative 5 squared, which is 25. So that's what goes in this blank right here. But whatever you add to one side, you have to add to the other. So I'm going to add 25 to the other side. Then this right here should now be a perfect square trinomial. So when I factor this is going to be x minus 5 squared. Do the same thing here. So we take the coefficient of y in this case, which is 8. I divide by 2, and whatever this quotient is, I'm going to square that. So that's 4 squared, which is 16. And so I add 16 to both sides. So that's what that step's supposed to look like. All right, so you're supposed to have shown, you need to show this step right here. Okay, then this right here, this trinomial, this quadratic trinomial is now a perfect square trinomial. So I can factor that as y plus 4 squared. And then when you add 4 plus 25 plus 16, you're going to get 45. All right, now, so you wrote it in this form, okay? But then you're told this. You will indicate the center and the radius also, and then if possible, simplify any radicals. So the center of the circle is going to be 5, negative 4, 5, negative 4, and the radius is going to be the square root of 45. Okay, you take the square root of this number here, but you got to simplify this. And so remember, the square root of 45, the largest perfect square that goes into 45 is 9, so I can write this as square root of 9 times square root of 5, which is 3 square root of 5. And so that equals 3 square root of 5, and this was what you needed to give as the radius, because it did say simplify any radicals. All right, so there's your work. This is the work you needed to show. This is part of your answer, this is part of your answer, and this is part of the other answer as well. All right, so that was the first one, problem 1. All right, now in problem 2, you're given this. So it says determine whether each relation, so you're given 4 relations here, and remember, a relation is a set of ordered pairs, and you want to determine whether each relation is a function or not. And so remember the definition of function. So for each definition, remember, for each x coordinate, there has to be only one y coordinate assigned to it. Okay, so let's look at letter A. So one of the things that we saw we could do was we could use a mapping. So for example, if you look at letter A right here, letter A. So in terms of a mapping, so here's my domain. Here is the range. So remember, for For each element in the domain, there's got to be only one element in the range associated with it. So when x is negative 2, my y value is 1. So far we're okay because for this x coordinate, I see only one y coordinate associated with it. When x is 3, that is assigned a y value of 2. When x is 7, that's assigned a y value of negative 1. When x is 0, that's assigned a y value of 0. When x is negative 3, that's assigned a y value of 6. So I took each of these and I wrote it in terms of this mapping. And notice for each of those x coordinates, there's only one y coordinate associated with it. So this is a function. So letter A is a function. All right, let's look at letter B. So the next relation. So the next relation, we have the set of these four ordered pairs. So let's use the same idea. So domain and range. All right, so when x is 2, that is assigned a y value of 6. When x is 3, that's assigned a y value of negative 1. When x is 0, that's assigned a y value of 4. When x is 5, that's assigned a y value of 6. Now don't rewrite the 6, only list it once, so do this. Now that confuses students because when they see two arrows going to the same y value, they think it's not a function. But remember, the definition of function says for each x coordinate, there's only one y coordinate associated with it, and that's the case here. It doesn't matter that the x values 2 and 5 have the same y coordinate. That doesn't matter. When x is 2, there's only one y coordinate, 6. When x is 5, there's only one y coordinate, 6. So this is a function. So letter B, so this relation is a function. All right, letter C. So in letter C, we have this set of ordered pairs right here. So let me go ahead and do the same idea of that mapping. So domain and then range. And when x is 2, that is assigned a y value of 4. When x is 3, that's assigned a y value of 4. Again, just list it once. When x is 7, that's assigned a y value of 4. And when x is 0, that's assigned a y value of 4 as well. That's still a function. Even though that all these x values have the same y value, that's still a function. Definition of function. For each x coordinate, there's only one y coordinate, and there is here. So that's a function. So letter C, that relation is a function. All right, letter D. So we have this relation here. So let me go ahead and move this part up here. So this is letter D. So we're going to use the same idea. We're going to use a mapping. So domain and then range. And remember the domain range. So when x is negative 1, my y value is 4. When x is 3, my y value is 6. When x is negative 1, I already have negative 1 listed, so don't list it again. That's going to confuse you. So I already have it listed. So when x is negative 1, my y value is 5. And then when x is 8, my y value is 2. Now, notice when x is negative 1, there are 2 y values associated with it. And so that is not a function. Okay? So remember, the definition of function for each x coordinate has got to be 1. So when x is negative 1, there are 2. So that's not a function. Not a function. So this one's not a function. All right? So that's problem number 2. All right, problem number 3. This time you're given a relation, and this time the relation, though, is written as an equation. And so in 3a, you have y equals 3x minus 4. Now, there are a couple of ways that you can approach some of these problems. So one way that you can approach this is to think, let me go ahead and rewrite this over, y equals 3x minus 4, is to think what the graph is here. Well, notice this is a linear function. That's a linear function. And so the graph of a linear function is a line. This is a line, and notice the slope is 3. So notice the slope is 3. And so that means the line rises. And so if in your mind, you know that the line does this then. That this will be the graph of the line. Whatever it is in the coordinate plane, and you could easily draw this. But once you know what the graph looks like in your mind, so this is what you see in your mind, you can use a vertical line test. And so notice no matter where I draw a vertical line, it intersects the graph once, which remember the vertical line test does apply the definition of function. So when x is, for this x value, there's only one value associated with it. So if this was the x axis and the y axis, so for this x value right here, there's only one y value associated with it. For this x value, there's only one y value associated with it. So the vertical line test does follow the definition of function. So since no matter where I draw a vertical line, it intersects it once, this is a function. So that's one approach. The other approach that you could have taken was to use a t-table. So if I use a t-table, and then let's see what happens. Remember the definition of function, for each x value, there's got to be one y value. So when I use a t-table, so for example, if I let x be 0, I get y equals 3 times 0 minus 4, which is 0 minus 4, which is a negative 4. So for this x value, there's only one y value, negative 4. All right, let's do a few more. When x is 1, I get y equals 3 times 1 minus 4. So that's 3 minus 4, which is a negative 1. So when x is 1, my y value is negative 1. So far that satisfies the definition of function. When x is, let's say, negative 2, just put any number you want right here. I'm using integers rather than decimals. You can use any real number, but integers make the process easier. When x is negative 2, I get y equals 3 times negative 2 minus 4. So that's negative 6 minus 4, which is negative 10. And if you continue the process, you're going to notice that for each of those x coordinates, there's only one y coordinate associated with it. So that's a function. So this is a function. All right, so 3a is a function. All right. Now, when we look at 3b, so 3b, we have this. So in one of your lessons previously, you graphed, and this was more part of my math lab lesson, you graphed this kind of equation. And so in 3b, where you had y equals x squared, you had to notice that this was a quadratic function, or a quadratic equation. And so when you look at, and when you recall what the graph of a quadratic equation looks like, is this parabola. So the graph is a parabola. And so it'll look something like this. And so again, using the vertical line test, no matter where you draw the vertical line, it intersects it once each time. So this is a function. So again, one approach is to use the idea of a graph to help you understand whether this is a function or not. The other approach is to use a t-table. So look at the t-table. So if I do a t-table, for each x coordinate, there's got to be only one y coordinate for it to be a function. So let's do the same thing. If x is 0, I get y equals 0 squared, which is 0. So far we're good. When x is 0, y is 0. But you got to do a few more. You can't just look at one or two of them. When x is 2, I get y equals 2 squared, which is 4. Okay, so far we're good. When x is 2, y is 4. When x is, let's say, 1, I get y equals 1 squared, which is 1. All right, so far that's still a function. Now let's do a few negatives. When x is, let's say, negative 2, I get y equals a negative 2 squared. Now negative 2 times negative 2 is 4. All right, but again, see this right here? It doesn't matter that these two different x values have the same y coordinate. All right, it goes back to this idea right here. It doesn't matter that all these x values have the same y coordinate. It's still considered a function. So if you continue your process, you're going to notice that for each x coordinate, there's only one y coordinate associated with it. When x is 2, the y value is 4. When x is negative 2, the y value is 4. It's nothing else. So this is a function. So again, you could use the idea of the graph if you knew what it looked like, and you did because you had lessons on this before, or you could have used a t-table. All right, so letter 3b, so this equation, this relation is a function. And then when we look at 3c, you have to notice, and the way you should have looked at that one was to notice that this is a circle. You've had enough experience in this course with circles, with the equation of circles, to notice this is the equation of a circle. So in 3c, so 3c where you had x squared plus y squared equal 8, this is a circle. All right, and so if you think about a circle in your mind, notice that no matter where you draw these vertical lines, it intersects it more than once in multiple places, and it doesn't have to be a multiple place. It could just be one place. So as you could have done this one and said automatically it's not a circle. I'm sorry, it's not a function. Now be careful. Some of you may say, well, it only intersects it once here. That's true, but it intersects it more than once in another place as well. All right, so that's not a function. It fails the vertical line test. Fails the vertical line test. So it's not a function. All right. So what you had the way you should have approached it this way is to notice this is a circle, and right away it's not a function because it fails the vertical line test. Now, if you wanted to use a t-table, this is what you should have done. You should have gotten y by itself. So if I get y by itself using a t-table, so if I get y by itself, notice what happens. I get y squared equals 8 minus x squared. Okay, so you subtract x squared from both sides. Then, let me go ahead and write this over. Then, to get y by itself, right now I'm squaring y. The opposite of squaring is the square root. So I'm going to take the square root of both sides. But remember, when you take the square root of an equation, two sides, when you take the square root, you got to remember that plus or minus. So the y and the y squared, I'm sorry, the square and the square root undo each other, so you get y equal plus or minus the square root of 8 minus x squared. Now let's use the t-table. Now some of you notice right away, hey, that's going to be a positive and a negative, and right away you notice it's not going to be a function because you have a positive square root and a negative square root. So for example, if I let x be 0, if I let x be 0, I get y equals plus or minus the square root of 8 minus 0 squared. So that's plus or minus the square root of 8, right? So that's a plus or minus 8. So what that means is if you think about domain and range, that mapping we did earlier, when x is 0, there are two y values, a positive square root of 8 and a negative square root of 8. So right away, that's not a function. All right. So, but the way I intended you to do this problem was to notice that this this equation is a circle because you've had enough experience with equation of circles to notice what the equation of a circle looks like. And so remember this: the center is 0, 0 here. The center is the origin, and the radius is the square root of 8. All right. So, but either way, it's fine. You can use the idea of the graph, or you can look at the equation using a t-table, and then see what you get from there to determine whether it's a function or not. All right. So letter C. This relation is not a function. It's a circle. Okay. So that is the key to quiz number 3.